In an audacious announcement, researchers have claimed to have discovered a planet unlike any we've encountered before. NASA, famous for its revolutionary findings, has shown that this planet is intriguing not only because of its size and position but also due to its emission of light that appears to be artificial. Could we be on the brink of uncovering information that may significantly alter our understanding of the cosmos? Could this discovery point toward the possibility of life on other worlds? By delving into NASA's groundbreaking findings, we will soon unravel the truth behind this astonishing phenomenon. In 2007, NASA launched the Dawn spacecraft with the goal of exploring some of the most fascinating objects within our solar system. Fitted with 3 ion engines, Dawn embarked on a journey beginning with a 14-month study of Vesta, the second largest asteroid in the belt. Dawn transmitted back highly detailed images and data, shedding light on Vesta's intricate surface and varied geological history. After completing its mission at Vesta, Dawn proceeded to the second phase of its journey, one that was likely even more thrilling, a comprehensive examination of the dwarf planet Ceres. Thanks to its ion engines, Dawn could break free from Vesta's orbit and head toward Ceres, a feat that would have been impossible with conventional chemical propulsion systems. These engines provided a steady thrust, allowing Dawn to travel vast distances and enter a stable orbit around Ceres. Discovered in 1801 by Italian astronomer Giuseppe Piazzi, Ceres is the largest object in the asteroid belt, located between Mars and Jupiter. For years, it was categorized as the smallest dwarf planet in the solar system until its reclassification in 2006. With a diameter of about 950 kilometers, Ceres stands as the largest and most massive body in the asteroid belt, making it one of the most captivating due to its unique attributes. Scientists eagerly awaited the first close-up images of this mysterious planet, which revealed brilliant spots scattered across its surface, particularly in a large crater known as Arcata. These bright spots sparked immediate speculation and curiosity within the scientific community. Prior to the Dawn mission, the best images of Ceres consisted of low-resolution, blurry shots taken by the Hubble Space Telescope. Very little was known about this dwarf planet, and the promise of detailed observation fueled excitement among astronomers and space enthusiasts alike. The Dawn mission aimed to enhance our understanding of the solar system's formation and examine the function of water in the development of planetary bodies. The bright spots on Ceres, also observed on other asteroids, might be made of highly reflective materials, possibly salts left behind by evaporated water. This discovery hinted at the possibility of cryovolcanism, volcanic activity that erupts water or brine instead of molten rock. But what exactly are these enigmatic lights, and what do they reveal about the true nature of Ceres? Could they be signs of ongoing geological processes or something even more extraordinary? Ceres stands out from other objects in the asteroid belt due to its size, mass, composition, and the potential presence of water and ice. Unlike the typically rocky asteroids, Ceres has a more comet-like composition, suggesting it could unveil more secrets about the early solar system. After 2 years in transit, the Dawn spacecraft finally neared Ceres in early 2015, marking a significant milestone as it prepared to offer the first detailed views of the largest body in the asteroid belt. As Dawn approached, the images became progressively sharper, revealing a world previously hidden from view. The first pictures showed a cratered surface, suggesting a long history of impacts. However, what drew the most attention were the dark areas with enigmatic bright spots scattered across rugged terrain. As the image resolution improved, scientists began to develop theories about the nature of these spots. Were they areas of ice reflecting sunlight, or could they be something even more remarkable? Speculation ranged from mineral deposits to potential indications of cryovolcanic activity. To everyone's astonishment, closer examination showed that the brightest spot wasn't just one feature but a collection of distinct areas. The most widely accepted explanation was that these were salt deposits left behind after water sublimated. This subtly suggested that Ceres had, or possibly still has, some form of geological activity capable of pushing water or brine to the surface, where it quickly dissipates, leaving behind bright reflective residues. These findings challenged previous ideas about Ceres, painting a picture of a more dynamic and intricate world than anyone had imagined. The possibility of subsurface water or brine pockets could have profound implications for our understanding of the potential for life elsewhere in the solar system. Ceres is often described as an icy world with a rocky yet porous surface. Unlike most asteroids, which are largely composed of rock and metal, Ceres stands out for its distinct composition. Its surface is a blend of water, ice and hydrated minerals, including clays and carbonates, giving it a structure that is less dense than its rocky neighbors. Based on this composition, Ceres may harbor significant amounts of water beneath its surface. Its outer layer is rocky but porous, trapping ice and various volatiles, making it resemble a comet more than a typical asteroid. It is believed that Ceres has a unique internal structure consisting of a rocky mantle and a core rich in water ice, which makes up about half of the planet's total volume. Ceres' mantle is likely a mixture of rock and brine surrounding a denser core, possibly made of silicates. The presence of substantial water ice raises the possibility that Ceres might have previously supported liquid water, especially if its core was heated by radioactive decay during its early history. This internal composition sets Ceres apart from its neighboring asteroids and opens up fascinating inquiries regarding the potential for geological activity and the role of water in shaping its development. But that's not all. The discovery of ammonia clays on Ceres suggests that this dwarf planet may have originated in the cooler regions of the solar system before migrating inward. The presence of ammonia could lower the freezing point of water, making it possible for surface brines to exist. These revelations about Ceres' composition and history not only deepen our understanding of this captivating dwarf planet but also provide valuable insights into the governing processes behind the formation and evolution of icy bodies throughout the solar system. Cryovolcanism is an intriguing and relatively rare geological process, especially when compared to the familiar volcanic activity on Earth. Unlike traditional volcanoes, which expel molten rock, cryovolcanoes, also called ice volcanoes, release materials such as water, ammonia, or methane. These substances can remain in liquid or gas form in extremely cold environments. Cryovolcanic activity on Ceres allows salty water to rise to the surface. When this briny water comes into contact with the vacuum of space, it quickly sublimates, turning from solid or liquid into gas. This process leaves behind glowing, reflective salt deposits that form the mysterious bright spots visible on Ceres. Further analysis of the bright spots in Ocata crater revealed that they consist primarily of sodium carbonate, a type of salt that forms when water evaporates. This strongly suggests that Ceres once had, or still has, subsurface liquid water. The presence of these salts, along with ammonia-bearing clays, supports the idea that Ceres experienced internal heating and possible cryovolcanic activity in the past. One of the most compelling aspects of the Dawn mission's findings was the discovery of a haze-like phenomenon above Ocata's bright spots. This haze appeared to form during daylight hours and dissipate at night, leading scientists to hypothesize that sublimating water vapor might be temporarily creating a thin atmosphere around the crater. This was a groundbreaking discovery, as it suggested that Ceres could still be geologically active, with ongoing sublimation of water ice or briny deposits. The implications for astrobiology. Ceres' unique characteristics make it a prime candidate in the search for extraterrestrial life within our solar system. While it lacks the thick atmosphere and surface oceans of planets like Earth, its subsurface reservoirs of water ice and brine raise intriguing possibilities. If liquid water still exists beneath its surface, it could potentially harbor microbial life, similar to extremophiles found in some of Earth's harshest environments, such as deep-sea hydrothermal vents or subglacial lakes in Antarctica. Additionally, the discovery of organic compounds on Ceres added another layer of complexity to its astrobiological potential. In 2017, Dawn detected aliphatic organic molecules in the Ernutet crater region. These molecules are essential building blocks of life, and their presence further fueled speculation about the possibility of prebiotic chemistry or even biological processes occurring beneath the surface. While no definitive evidence of life has been found, Ceres remains an intriguing target for future exploration. Scientists are now considering new missions that could involve landers or even drilling probes to investigate the subsurface environment directly. Such missions could confirm the presence of liquid water, analyze the composition of salts and organics in greater detail, and provide more concrete answers about Ceres' potential to support life. The legacy of the Dawn mission. Dawn's mission officially concluded in November 2018, when the spacecraft depleted its fuel and was left in a stable orbit around Ceres. Although it no longer transmits data, its legacy continues to shape our understanding of the early solar system and the role of water in planetary evolution. The insights gained from Dawn's observations of both Vesta and Ceres have expanded our knowledge of how dwarf planets and large asteroids formed, highlighting the complex interplay of geological and chemical processes in shaping these celestial bodies. Ceres, once a mere dot in telescopic images, has now been revealed as a dynamic world with a rich history. The bright spots that once puzzled scientists have led to profound discoveries about planetary geology, water ice, and even the potential for life beyond Earth. As humanity continues its quest to explore the cosmos, Ceres stands as a reminder that some of the most fascinating discoveries may be hidden in the least expected places, waiting for the right technology and curiosity-driven exploration to uncover their secrets. Observed by Dawn, these fluctuations are believed to be the result of water sublimation, suggesting that cryovolcanic activity might still be occurring or may have happened recently on Ceres. In addition to Spot 5, Ceres hosts several other bright spots, each with its own distinctive characteristics. These spots are not restricted to a single location but are dispersed over the entire surface of the dwarf planet, indicating that cryovolcanism could be a widespread phenomenon on Ceres. The presence of these bright spots highlights the dynamic and active nature of Ceres, challenging the previous belief that it was a geologically dormant world. As the Dawn spacecraft continued to send back more detailed images, it revealed a surface marked by a variety of craters, each telling a unique part of Ceres' history. The discovery of these features on Ceres truly revolutionized the way we view this dwarf planet. With its ice composition and signs of possible cryovolcanic activity, many of the assumptions previously held about bodies in the asteroid belt no longer apply. No longer considered simply a frozen relic, Ceres is now seen as an active and evolving world. The bright spots, particularly in Ocata crater, continue to generate curiosity among scientists, as they might provide a glimpse into processes that are not only geological but potentially linked to the planet's ability to harbor liquid water. The study of Ceres has far-reaching implications beyond just understanding this particular dwarf planet. By examining its internal makeup, surface features, and deposits, researchers can gain important insights into the larger dynamics of icy bodies in the solar system. The materials found on Ceres, water ice, ammonia, clays, and salt deposits, could offer valuable clues about the chemical composition and conditions of other similar celestial bodies, both within our solar system and beyond. Moreover, the potential for cryovolcanism on Ceres opens up exciting possibilities regarding the broader geological activity of icy moons and dwarf planets. This phenomenon is not just limited to our solar system but could extend to exoplanets as well. It suggests that environments once thought to be static or inhospitable might, in fact, be dynamic and capable of supporting complex processes. Could this also mean that other distant worlds, once thought to be frozen and lifeless, could harbor conditions conducive to life? NASA's Dawn mission stands as a testament to the power of space exploration. The data it has returned has already reshaped our understanding of the solar system's formation and evolution. As we continue to probe deeper into Ceres and other distant celestial bodies, each discovery adds one more piece to the puzzle of how planets, moons, and other celestial objects change over time. For now, the bright spots on Ceres remain one of the most intriguing phenomena in our exploration of the cosmos, but they are only the beginning. As technology advances and more missions are launched, the possibility of even greater revelations looms large. Ceres, once an obscure and forgotten dwarf planet in the vast asteroid belt, now stands as a beacon of mystery and potential. Its surface, internal structure, and enigmatic bright spots may one day provide the key to understanding the early solar system and the processes that led to the formation of planets and other bodies. The potential for life, or at least the ingredients for life, on Ceres remains an exciting possibility that continues to inspire researchers and space enthusiasts alike. As we continue to explore Ceres and other distant worlds, the line between science fiction and reality becomes increasingly blurred. The idea of life on other planets, once a subject of speculation and imagination, is now a real and serious question. Could microbial life exist in the underground water pockets of Ceres? Could the conditions on other icy moons be suitable for life, whether in forms we recognize or something entirely new? These are the questions driving the next wave of space exploration, questions that may ultimately lead to unlocking the universe's greatest mysteries. As we strive to send more spacecraft, and possibly humans, to explore these distant worlds, the discoveries made by Dawn and future missions will continue to shape our understanding of what is possible in the universe. From Ceres' icy surface to its bright spots, which may indicate the presence of liquid water, this dwarf planet serves as a reminder that there is still so much we don't know about our solar system and its many wonders. The mission to explore Ceres is far from over. With each new discovery, we come closer to uncovering the secrets of this fascinating world. Let me know your thoughts on the findings about Ceres in the comments below. If you found this video fascinating, don't forget to hit the like button and subscribe for more updates on the latest space missions and discoveries. As more data from the Dawn mission continues to arrive, scientists are only scratching the surface of what might be learned about Ceres. The bright spots, in particular, have sparked not only scientific curiosity but also public imagination. Their mysterious nature raises more questions than answers, fueling ongoing research and investigation into the possibility of further geological, or even biological, activity. The fact that these spots are spread across the surface suggests a systemic process at work, something significant happening beneath the surface, potentially involving briny water. This could create an ideal environment for future exploration. While the Dawn spacecraft has already made great strides in unveiling the wonders of Ceres, much remains to be discovered. As technology advances, we can expect even more detailed images and measurements that will further refine our understanding of the planet. This will allow scientists to test existing hypotheses and perhaps develop new theories based on new findings. Every new image or piece of data sent back from the spacecraft brings us one step closer to uncovering the full story of this icy dwarf planet. As researchers analyze the wealth of data sent back by the Dawn spacecraft, new insights into Ceres' past and present are emerging. One of the most compelling discoveries is the evidence of subsurface reservoirs of liquid water, a factor that raises intriguing possibilities for astrobiology. Scientists believe that beneath Ceres' icy crust, pockets of briny water might still exist today, providing a potential habitat for microbial life, if the necessary chemical conditions are met. The presence of salts and ammonia-rich clays on Ceres also hints at a complex geochemical history. These materials suggest interactions between water and rock, processes that could have persisted over geological timescales. If confirmed, this would position Ceres as one of the most intriguing bodies in the solar system, alongside Europa and Enceladus, both of which are thought to harbor subsurface oceans. Future missions may focus on directly probing these subsurface environments. A lander or drilling probe could provide definitive answers about the composition of Ceres' interior and the potential for habitability. Some scientists even speculate about sending a rover equipped with advanced instruments to explore the bright spots up close, analyzing their composition and searching for organic molecules that could be linked to biological processes. Beyond its scientific importance, Ceres also presents a unique opportunity for future space exploration. As the largest object in the asteroid belt, it could serve as a waypoint or resource hub for deep space missions. With its abundance of water ice, Ceres might one day support human exploration efforts, providing water for drinking, oxygen for breathing, and even hydrogen for rocket fuel. In this way, studying Ceres is not just about understanding the past, it's also about preparing for the future of space travel. As space agencies and private companies plan more ambitious missions beyond Mars, the role of celestial bodies like Ceres in humanity's long-term spacefaring aspirations cannot be ignored. Could Ceres become a stepping stone for future missions to the outer solar system? Could its water resources be harnessed for space colonization efforts? These are questions that will shape the next phase of planetary exploration. For now, Ceres remains an enigmatic world, one that continues to surprise scientists with each new discovery. The data gathered by Dawn has revolutionized our understanding of this dwarf planet, but many mysteries remain. As technology advances and our exploration capabilities grow, the secrets of Ceres may one day be fully unveiled, shedding light on the history of our solar system and perhaps even the possibility of life beyond Earth.